Okay, so we're going to start off this week by looking at section 3.3. The section is called the Factor Theorem. Just as a reminder, we've used this term a lot, okay, a root or a zero. Okay, a root or a zero is basically a number that you plug in for x. Do all the arithmetic out, and the answer that you get is 0. Right, so if I had a problem like this, if I said, what's the root? What number would I plug in for x to make that 0? It would be 1. Okay, the root to this equation is 1. Because 3 times 1 is 3. And then 3 take away 3 gives me 0. Some equations have more than one root. Depends on how many times it crosses the x-axis. Right? A line can only cross the x-axis one time. But a parabola could cross twice. Right? So different kind of functions have different numbers of roots. So what we're going to do is we're going to use long division to try to find roots of polynomials, or also to try to factor. Okay, and first thing, I'll show you an example with just numbers. Okay, and then we'll try one with polynomials. All right, so let's say I wanted you to factor the number 12. Okay, to factor basically means write it as a product of two numbers. If I want you to factor 12, and I tell you that 3 is a factor, what can you do with the 12 and the 3 to find the other factor? Yep?
Divide 12 by 3.
Yeah. So basically, if you know 3 is a factor, if I tell you that, that means 3 times something is going to give you 12. Well, if you divide each side by 3, then you can solve for something. Okay, whatever that happens to be. In this case, 4. All right, so as long as you know one factor of something, you can use division to get the other factor. All right. And notice here, when you divide it out, 12 divided by 3, what's the remainder? 0. All right, so if a number is a factor, when you divide it in, it goes in evenly. No remainder. If I took 12 and divided by 5, okay, I get remainder 2. Because I got a remainder, that means 5 doesn't go into 12 evenly. 5 is not a factor of 12. Right? So we're gonna use that idea too. If you divide something into something else and you get a remainder of 0, that means it's a factor. Right? So 6 is a factor of 12. 3 and 4 are factors, and 1.
2.
And 2. Did I say 2? Yeah, 2 is a factor of 12 as well. All right. Any question on that? Right, that's basically what I just said. Okay, if you take A and divide by B and you don't get a remainder, then you know the number you divided by is a factor. Like 12 divided by 2. Okay, goes in without remainder. Okay, and if we can factor a polynomial, that makes it easier to find the roots. For example, okay, this one's not overly hard, but if I asked you to find the roots, sometimes writing it like this is a little challenging. But if we rewrite it like this, now it's very easy to see the two numbers we could plug in that would make them 0. Negative 1 is a number you could plug in and get 0, and negative 2. Sometimes when it's written this way, you can't see that as easily. Does everyone see how if you plug in negative 1 here, negative 1 plus 1 is 0, and then negative 2 plus 2 is also 0? So each of those numbers is a root. Right? So that's why we would factor. Makes it easier to find roots. So now I'm going to explain how we can do that division process with a polynomial. Right. Writing all the steps out for how to do this, it's kind of lengthy. So if you're that kind of person that you see an example and that's how you learn, you just watch the example, then maybe you just want to wait till I do the example. If you really like to see what's the method, step 1, 2, 3, 4, 5, maybe you want to write down all the steps. Right? But we'll do both. All right. The first thing you have to do anytime you're going to do division is if the dividend, that's the thing on the inside, okay? That's the dividend. If the dividend is missing any terms, you have to fill in a 0 for that term. It's like a placeholder. Right? So let's say I had something like x cubed plus x plus 4. Well, I'm missing the x squared term. So in order to keep everything lined up when I do the process, I'm just going to insert 0 x squared. Just so every power is represented. Power of 3, power of 2, power of 1, and my constant. Okay, so fill in zeros for anything you're missing. Okay, the second step. Okay, you're going to divide the first term of the divisor, that's the thing on the outside, into the first term of the dividend. Right? People want me to go through an example and do each step as I write it, or you want me to just put all the steps up first and then do the whole example at once? Just do the whole example at once? All right, so we'll just put all the steps up now. All right, so divide the first term of the divisor into the first term of the dividend. Okay. Next, you're going to get an answer when you do that. You're going to take that answer that you got in step 1, and you multiply it by each term in the divisor, and you've got to put your answer under the like terms. Okay, so when we multiply it out, we're going to line things up in columns. This is very similar to how you do long division with just numbers. Okay, if you had something like, just like this. I don't know, just make something up. 52. Take the first term here, which is basically just 3, and divide it into the first term of your divisor. 3 goes into 5 one time. Next, you multiply your answer from step 1 by each term and write the result under the appropriate column. Right? So 3 times 1, we put our 3, and we put it under the first column. What's the next thing we do with the 5 and 3?
Subtract.
Yeah, we'd subtract. That's the next step here. Okay. Subtract the columns that you just created. Yep, multiply your answer from step 1 by each term in the divisor, and then you put the result under the appropriate column. And that says subtract columns from step 2. Oh, is it the wrong number? Yeah, my numbers are off by 1. Thank you. Multiply your answer from step 2. Subtract the columns from step 3. Yes. Thank you. Okay, and then after you subtract your numbers, what do you do next?
Bring them down.
Yeah, bring down. Okay, so now you bring down the next term, and you keep repeating this process until you don't have a remainder. Or your remainder is smaller than the number on the outside. Okay? It's basically the same idea with a polynomial. Okay, so in this case, 3 goes in 7 times. I'd multiply my answer, 3 times 7. I'm lining up my tens digit and my ones digit. We're not going to have tens digits and ones digits quite, this elementary, but same idea. And then I subtract. And now this number is less than that number, so I can't go anymore. Remainder 1. All right, so if you understand how to do long division with numbers, polynomial follows the same idea. Divide, multiply, subtract, bring down. You follow that basic process. Yep.
synthetic division?
Yep, we're going to talk about synthetic division tomorrow, but yes, you can.
Because I don't understand this way. Like I tried to figure it out last year, but I ended up having to switch to synthetic division.
Yeah, you can use synthetic. The only thing with synthetic is you can only use it on certain kinds of problems.
When they put a number in the front, it's there.
Yeah, you can only use synthetic when, I'll show you an example. You could here. This is a problem you could use synthetic with. But if I just make one small change, now it's not a problem you could use synthetic with. Okay? But yes, when you can use synthetic, we will. Anybody remember that from last year, synthetic division? Couple people? Yeah. We'll talk about that tomorrow. Anybody need to copy down any more steps?
Yeah, I still have to.
All right. So what I'll do is let me let's go like this. All right. So in this one, our divisor is x minus 3. Our dividend is x cubed minus 8x plus 3. I'll make it bigger as soon as everyone gets the steps. And you know what? Let's see if I can just. All right, so I'll kind of work through the first one with you and show you how it works. If I'm missing any terms, fill in as 0 for a term. Okay. Am I missing any terms in my dividend? Yep.
Your x squared.
Yeah, I'm missing the x squared. So first thing I'm going to do is just rewrite it. If I don't, when I get an x squared term, I'm going to have nowhere to line it up. Okay, I'm creating a column. I'm creating space for it. All right, now step 2. Okay, divide the first term of the divisor, which is x, into the first term of the dividend, which is x cubed. Okay, so basically we're doing this. What's x cubed divided by x?
S cube.
X to the what? Yep, x to the second. X cubed divided by x, you subtract your exponents, and get x squared. Okay, any questions on that? Okay. Okay, step 3. Take x squared, multiply it by each term, and put the result under the appropriate column. Line up your like terms. Okay. X squared times x, x cubed. X squared times negative 3, negative 3x squared. Okay, the next step, subtract the columns we just created. Does anybody know what you have to be careful about here when you subtract? How many terms are there on this row? 2. And you're subtracting both of them. So my advice is put them in parentheses. Okay, now, if you've done the first couple steps right, what should always happen is something cancels out. What's x cubed minus x cubed? That should happen every time. If it doesn't, something's wrong. Right? 0 minus 3x squared plus 3x squared. Okay. And now we just repeat the process. Bring down the next term. Okay, and we know we're done either when we don't have a remainder or this exponent, which is now a 2, is smaller than this exponent, which is a 1.
How did you get the minus 8x?
I just
Oh, you just brought it down.
brought that down. Yep. Yep.
When you put the subtraction sign in front of the parentheses, is it safe to say we can switch the symbol inside?
Yeah, it's like you're distributing that negative, which really switches the sign. Yep. Some people just forget they'll write 0 minus 3 and put negative 3 here, which is wrong. It's positive 3. All right. Now, divide the first term of the divisor, which is x, into the first term here, 3x squared. Okay. What do you get if you do 3x squared divided by x? Yep. 3x. Good. Right, now I'm going to do step 3, multiply that answer by each term and line it up in the correct column. 3x times x, 3x squared. 3x times negative 3, negative 9x. And at the subtraction step, I always put in parentheses. Here's what's going to cancel. 3x squared minus 3x squared. That's gone. Okay. Negative 8x minus 9x. So that's going to become negative 8 plus 9, or 1. Okay. Negative 8 minus 9 is plus 1. And then we're going to bring down our last one. Yep.
So is there any way that you can like get it so that you don't have to keep flipping all the signs? Could you make the term like positive?
No, you just have to remember to do that. Yeah, you just have to remember that. Okay, and this is going to be the last one, because this is a degree 1. This is a degree 1. If we do it one more time, we're going to be done. Okay, what's x divided by x? 1. Okay, multiply it back out. 1 times x. 1 times negative 3. And now just remember, you're going to subtract the whole thing. X minus x is gone. What's 3 minus minus 3? Positive 6. That's my remainder. Okay. So one way you could write the answer is your quotient is x squared plus 3x plus 1. And your remainder is 6. Okay. Any questions on it? Yep.
Let me do the last step again.
This last step right here.
Yeah.
So we do x minus x, and that cancels out. And then we have 3 minus minus 3. So minus a minus becomes a plus. So 3 plus 3 gives me 6. It's a little tricky. There's really no simpler way to explain it. You just got to get used to it. Another way you can write your answer, okay? Just like in long division. Okay. This would be 5 remainder 1, right? So I could write my answer as 5 plus my remainder over 3. 16 divided by 3 is 5 1/3. Right? Remainder over divisor. Well, you can do the same thing with this. You could write your answer as your quotient, x squared plus 3x plus 1, plus your remainder over the number that was originally on the outside, x minus 3. Both of these are correct ways to write the final answer. It's just the difference between writing your answer 5R1, okay, like 5 remainder 1, or writing your answer as 5 plus 1/3. These are the same thing. Just like these are the same thing. All right, we're definitely going to try another one of those. All right, and as Tyler said earlier, this is a problem you could use synthetically.
It's way easier.
Okay, so synthetic is going to be a lot faster. This is not a problem you can do synthetic with. So if you don't know how to do the long division on this one, you can't do it. This problem was missing a couple spots. I already filled in zeros for you. Okay, it was missing x squared, and it was missing the x. All right, so step 1. Take that and divide by that. Okay, what do you get if you take 2x to the fourth and divide by 2x squared?
S squared.
Yeah, just x squared. Any questions on how we got x squared? You can check it, because when you take this and you multiply by that, you better get that. If you don't, something's wrong.
I just missed like.
Oops. All right, so here, let's just go back. You're taking 2x to the fourth, and you're dividing 2x squared into it. So the 2's are gone. Same base, subtract your exponents. X to the fourth divided by x squared is x squared. Or think of it this way. X to the fourth, x squared. Those are gone. Those are gone. 2x, or x squared, is what's left. Does that make sense too? No, wait, yeah. All right, multiply it back out. X squared times 2x squared is 2x to the fourth. Amanda, what's x squared times x? X to the third. Okay, Tommy Lee, what's x squared times 1?
X squared.
Yeah, just x squared. And my hint, what do I want to remember to put around all that stuff in blue?
Parentheses.
Yep. Because we're going to subtract all of it.
So that's going to make all those signs negative, correct?
Yeah. So it's 2x to the fourth minus 2x to the fourth. So that one's gone. This one's going to become a minus. Negative x cubed minus x cubed. Negative 2x cubed. 0x squared. Take away x squared. What happens? What happens there?
Oh, cancel.
0x squared. Take away 1x squared. Negative x squared. And bring down your next term. Notice the exponent here is now a 3. That one's a 2. We keep going until this number is less than that number. Right? Before it was a 4. Now it's a 3. It keeps going down each time we do this. Yeah?
How did you get negative 2x to the third?
We had negative 1x cubed. Take away x cubed. So negative 1, take away 1 is negative 2. Right? If you want to put the 1's in, we can do that. Negative 1x cubed, take away 1x cubed. Some people write 0, but remember, it's not negative 1 plus 1. It's negative 1 minus 1, which is negative 2. All right, and let's see what happens here. What's negative 2x cubed divided by 2x squared?
X squared. I mean x.
X.
Negative x.
Negative x. So 2 divided by 2, those cancel out. All you're left with is a negative. 3 minus 2 gives me x to the first. Okay, so negative x to the first, which we could just write negative x. Okay, multiply it back out. Taryn, what's negative x times 2x squared? Yep, negative 2x cubed. Kyle, what's negative x times positive x?
Negative x squared.
Negative x squared. And the last one, I'll do this. Negative x times 1. Negative x. Okay. And watch what happens when you subtract here. What's negative 2x cubed minus 2x cubed?
Cancel out.
They cancel out. That's negative 2x cubed plus 2x cubed. How about here? Negative x squared minus x squared.
Cancel out.
It's going to cancel out again. It's negative x squared minus a minus becomes a plus. So negative x squared plus x squared. Sometimes that happens. You get two things that cancel in the same step, and now we're done.
Just
Just
what?
my remainder is 0 minus minus x. What's 0 minus minus x?
Negative x.
Not 0 minus x,
So it's 1x.
minus
Oh.
minus x.
2x.
0 minus minus 1.
And 1x. It's bx.
Minus a minus becomes plus. Yeah, with the long division, it's easy to get tripped up by the simple, like, second grade arithmetic stuff. Okay, so just be careful with your minuses. And what number do I have to bring down? This is a degree 1. That's a degree 2. You're done. You can't divide x squared into x. This is too small. Okay, so my quotient is x squared minus x. My remainder, x minus 2. Okay, that one's a little bit harder. Okay, on a test, you wouldn't have more than one like that. Most of them on the test, you can use synthetic division with. But there might be one you can't. All right, so here, really, just listen to me with this part. You don't have to write this part down. Okay, what I'm saying here is anytime you divide two things, okay, you always get a quotient and you get a remainder. Well, if the only thing that we want to find is the remainder, and we don't care what the quotient is, okay, I just want to say, what would be the remainder if you did this? There's a fast way to find a remainder. Not the quotient, but you can find the remainder very quickly. As long as you divide by something relatively simple. Okay, the last problem, we divided by something that would have been too complex to use this. But this would have worked in the first problem. Okay, so if you have a polynomial, and you divide by x minus a number. Okay, so think of something like this. And I want to know the remainder when I do this out. All I have to do is take the number after the minus sign, which in this case is what? Just the 2, and plug it into the top. This top part is f of x. So plug it in. In this case, you'd have 2 squared is 4. 3 times 2 is 6, plus 1. I have no idea what the quotient is, but if I divide this out, you're going to get a remainder of 11. If I want the quotient, I got to go do it the way we just did before. Right? But it only works if you divide by x minus a number. Wouldn't work for something like that. That's x squared. Okay. What if I had something like this? If I had a plus sign, how could I think of that as x minus a number? Yeah? Yeah, you could think of it like that. So it does work if you have a plus sign. Just think of, okay, now I'm plugging in negative 2, not positive 2. All right, so any question on that idea? Okay. One other thing. Because x minus 2 had a remainder, it didn't divide in evenly. We could say x minus 2 is not a what of the top. It's not a factor. Okay? If I had divided it and it went in without remainder, then I would know it's a factor. Okay? But because this is a remainder, that does not divide into that evenly.
Where did the 6 come from?
The 6, just plugging in 2. So 2 squared plus 3 times 2 plus 1. You got to be very careful, though, that you plug in the number after the minus sign. So block the minus sign, look at the number that's after it. Don't plug negative 2 in, okay? Unless you had this case. Yep.
Where'd you get
2, I just made this problem up. That's just what I divided by. I got the 2 from right here.
So like, how do you use this for a real problem though?
So let's do these 2. I want to find the remainder when I take f of x divided by h of x. Okay, so just find the remainder. So I can write it out. X cubed minus 2x squared plus x minus 5. Okay, what number here is very important to help me find the remainder? What am I going to use as my number I plug in? Yep.
3.
I'm going to use the number after the minus sign, 3. And where do I plug it in?
To the x value.
In which one, the top or the bottom?
Top.
Top. Plug it into the top. So what you need to find is this. What is f of 3? So we get 3 cubed is how much? 27. 3 squared is times 2, minus 18. Plus 3, minus 5. All right, so we got 27 minus 18 plus 3 minus 5. The remainder here is 7. So if you did all the work out to get the quotient and remainder, that's what the remainder will be, 7. Okay, without having to do out any of the long division.
Wait, so that's what it will be?
That's what the remainder will be. If you want the quotient, you still got to go through and do all the work.
I don't understand why this is like useful though.
If all you want is the remainder, because what does the remainder tell you? Remainder is very helpful.
The end behavior?
No, not the end behavior. What does that mean? Because I got a remainder when I tried to divide these two.
That's not a factor.
X minus 3 is not a factor of the top. So then if I asked you to factor this, it's not going to factor as x minus 3. It doesn't go in without remainder. Right? So a lot of times I'm going to ask you, is the bottom a factor of the top? How do you check it? Divide them and find the remainder. If it comes out to 0, then it is a factor. So I could ask you like a yes-no question. Is this a factor of the top? The answer, no. Not in this case.
So you can't do x plus 1 on the bottom, right?
Yep, we're going to do that one separate now. Yep.
You scroll.
So we're going to find the remainder when we divide by h of x. We just did that. And now we're going to divide by something different. Okay, just a second problem. I just decided to reuse the same numerator. Okay, so now we'll divide by g of x. Okay, if you don't want to use the remainder theorem, you don't have to. You could just do out the long division or synthetic division and find the remainder that way. You're going to get the same answer. Okay, but this is faster if they don't ask for the quotient. That's f of x. And this time g of x, x plus 1. So what do I have to find this time? Right, you're going to look at the number that comes after the minus sign. Right, so when I see a plus, I usually rewrite it as minus minus 1. Okay. If you can figure out what this is, you'll know your remainder. All right, Jamie, what's negative 1 cubed? Yeah, negative 1 times negative 1 times negative 1, just negative 1. Negative 1 squared is positive 1 times 2. Okay, still have that minus in front. Plus negative 1. I'm just going to write minus 1, minus 5. All right, so we get negative 1, minus 2, minus 1, minus 5. So when you divide these two things, the remainder is negative 9. More importantly, the bottom is not a factor of the top.
So when would it be a factor?
What would be a factor? I'd have to figure that out. Yeah, that could be pretty hard to figure out. But this one is not a factor of the top.
How do you know? When you ask us to figure this out, you're going to ask us like, is x minus something a factor of? That's how we'll figure it out, or do we pick what?
Yeah, you could have a question like that. It would be like a yes or no.
Okay.
Is this a factor of this? Yes or no? And then you do find the remainder. If it comes out to 0, it's a factor. If it doesn't come out to 0, it doesn't go in evenly, It's like doing 12 divided by 5, not a factor.
Okay, so now x plus 1 is actually like x minus 1.
X minus minus 1. Because I have to write the bottom as x minus a number. And look at the number after the minus sign.
Okay.
All right. If you want to keep it as plus, that's fine. Just remember in your head, if you see a plus, it really should be a minus if you're going to use this trick. Okay. So the remainder theorem, if you look at it in your book, it's written like that.
Okay, so if it's x minus 1, it's actually just a positive 1 that you're putting in.
Yeah, it's like the opposite of the number in the bottom. Yep.
That's done.
All right, so this is kind of getting at what I've been saying all class. So let f of x be any polynomial you want. If you divide by x minus c, that's a factor only if you plug this number in and get a remainder of 0. That's basically what that is saying. Right? X minus c is a factor of the numerator if you plug c in and you get remainder 0. Right? That's all you really have to remember from this idea. Right, so now we're going to do one that actually works. We're going to do one that I'm telling you, this is a factor of that. And I'm going to use the factor theorem to show it. Right, so basically what I'm going to do is I'm going to divide these two things, and all I want to know is the remainder. If x plus 2 really is a factor, what am I hoping to get for a remainder?
0.
I'm hoping I get 0. Okay, and I will when we do it out. Right, so I'm going to take x cubed plus 5x squared plus 5x minus 2. I'm going to divide by x plus 2. And we hope for a remainder of 0. That's what we're hoping for. Okay, a couple ways you can get the remainder. Do out all the long division. Do the whole process. Okay, if you like synthetic division and you know how to do it, do all that out. Or, what number can I just plug into the top and do it that way? Yeah. All right, so instead of thinking of the bottom as x plus 2, think of it as x minus minus 2. You're always looking for the number after the minus sign. That's the number you plug in. Minus 2 is the number after the minus sign. Okay, plug it into the top. Minus 2 cubed plus 5 minus 2 squared plus 5 times negative 2 minus 2. Let's see if we get 0. Negative 2 times negative 2 times negative 2, negative 8. Negative 2 squared is 4 times 5, 20. 5 times negative 2, negative 10. Okay, negative 8 plus 20 is what?
Positive 12.
12 minus 10 minus 2. What's 12 minus 10?
Oh, 2.
And 2 minus 2?
0.
Gave me a remainder 0. So, that means that x plus 2 divides into the numerator without a remainder. It is a factor. So if you were going to factor the top, that is a factor. How would you get the other factor? Because it's going to factor into two things.
Do you mean the x, or what do you mean?
So like if I said to you, here's the number 15. 5 is a factor. I'm telling you 5 is a factor. How do you get the other factor?
15 divided by 5.
You divide by the one you know is a factor, and you get the other one. Well, I'm telling you x plus 2 is a factor.
So we divide.
Yeah. If
So you
you,
have that long division out anyways.
yeah, if they wanted the other factor, that's when you do out the long division. And the answer that you get, that's the other factor. Okay? And I guarantee it's going to go in evenly. We just proved it. you're not going to get a remainder. Okay, on this problem, I'm not going to do that. Okay? But if you wanted the other factor, do out the long division, and you will get the other factor. I don't know what it is. I'd have to do it out.
So that would be the quotient, right?
That would be the quotient, yeah. The quotient is the other factor. Just like here, 5 divided by 15, 3 is the quotient. 3 is the other factor. You multiply by 5 to get 15. Okay, any question on the remainder of 0 here? All right, so just some kind of equivalent statements, things we've been saying that all mean the same thing. C is a solution to the equation f of x equals 0. What that means is C is a 0. We could also say C is a root of the function. Okay? These all mean the same thing. Okay? If C is a root, we just went through this in the last problem. X minus C is a factor. You could also say that C is where it crosses the x-axis. Okay? All these things mean the same thing. We haven't really looked at it graphically today, but we could. Okay, so if C solves this equation, you can call it a 0. You can call it a root. X minus that is a factor. Or you can say C is where it crosses the x-axis. All that stuff means the same thing. Okay, and yeah, these will be our last problems. All right, so what I'm asking you for in example 5, I'm asking you to find a polynomial that would cross the x-axis in those 3 spots. I want it to cross at -2, +1, and +3. I'm telling you that -2 is a 0 of the function we're trying to find. I'm telling you that 1 is a 0 of the function, and 3 is a 0 of the function. What's another way to say 3 is a 0 of the function? You could say 3 is a root of the function. What's another way to say it? There's one way up here that's very important to answering this question. If 3 is a root, or 3 is a 0, 3 is also an x-intercept, but that doesn't really help.
A factor?
What's a factor?
3, 1, and -2.
So 3 is a root. 3 is a root. What would be a factor then? X minus 3. We're just taking what we know and we're saying it a different way. If 3 is a root, x minus 3 is a factor. Okay? What if 1 is a root? What else would be a factor? X minus 1. Now be careful with this one. What if -2 is a root? Yep. X plus 2 is a factor. Okay. Guarantee if you graph that, you'll get a polynomial that crosses the x-axis in those 3 spots. Okay. Now you could FOIL it out, x squared, and do it all out, but they didn't ask us to. Okay. Let's just graph it and see what it looks like. Okay. If we did it all out, it might look something like this. I'm going to just type it in the way it is. X plus 2, x minus 1, and x minus 3. Okay, and notice it crosses the x-axis at -2, +1, +3. Perfect. Okay. So if I wanted to give you guys a problem on a test and I wanted to go through certain things, this is how I could force the picture to go through certain numbers. If I wanted to go through 5, I make that a factor. If I wanted to go through 6, I make that a factor. All right. Any question on that one? Does anybody need me to actually multiply that out? Okay, you could multiply it out, use FOIL or distributive. But they didn't ask us to, so I'm not going to do it. All right, last problems. Okay, now we're going to think about it graphically. We're going to find the roots. I want you to find what numbers you'd plug in for x and make the answer come out to 0. Okay, we're basically looking at it this way. We're going to find where the graph crosses the x-axis. We're going to find the roots. We're going to find the zeros. We're going to find the numbers we plug in that make the equation equal to 0. All the same thing.
On that one, like, what did you do to get the x?
So all you do is take each one of these numbers and put x minus in front of it. So like x minus -2, x minus, put in a 1, x minus, and fill in a 3. You just write x minus and then put each of those numbers. That's it. This one changes to a plus because it's x minus minus. Minus a minus becomes a plus.
I don't like understand the wording of the problem, but like the degree.
Degree 3? Oh, yeah.
What are you talking about?
So degree 3 just means if you FOILed this out, it would have x cubed in it. I'll just do it quick. So I get x squared minus x plus 2x minus 2. That's what you get if you FOIL out the first two. So what is that? X squared plus x minus 2. Okay on that step? Just FOILing? Now I'm going to FOIL it again. X cubed, there's my degree 3 right there. Minus 3x squared plus x squared minus 3 minus 2x plus 6. So you get x cubed minus 3 plus 1 is minus 2x squared minus 2x plus 3. Here's the answer if you do the whole thing out. This and that are exactly the same thing. There's your degree 3. Okay, it just means it's going to be the highest exponent. Yeah, that's a good question, because you don't see that when you write it this way. But if you do it all out, then you would. So try typing that in. It's the exact same graph. All right, so this one and this one. All right, so the last two problems, they want us to find the roots. Okay, one we're going to do by factoring, one we're going to do just using the calculator. Okay, the first one, they give us a hint. Use factor by grouping. Okay, when you do factor by grouping, you factor what you can out of the first two, and then separately factor what you can out of the last two. Okay, anybody tell me what the first two terms have in common? They have an x squared. What would you have left if you factor x squared out of x cubed? X. And what if you factor x squared out of 2x squared? Plus 2. Okay, and what can I factor out of the last two terms? Yeah, I can factor out a -4. If you factor a -4 out of the x, what does that leave you with? And what if you factor -4 out of -8? Plus 2. See what just happened there? X plus 2, x plus 2. That has to happen when you do factor by grouping. So I have to give you a problem where the same thing gets inside each parentheses. If it doesn't, you'd be stuck right here. You wouldn't be able to go any further. Now, what do each of those have in common? They each have an x plus 2. So I'm going to factor that out. If I take x plus 2 out of the first one, what's left?
X squared.
Just x squared. If I take x plus 2 out of the second one, what's left? And we're trying to get this equation to equal what? 0. So if you multiply two things together and get 0, either the first one has to be 0, or the second one has to be 0. What number would make this first one 0? That's one place it's going to cross the x-axis. That is one of the roots of this function. Yep?
Can't you factor out x squared minus 4 again?
Yeah, you could factor this down more. Like you could factor it as x plus 2, x minus 2. Or you could leave it like this and just solve it. Either way. Either way is fine. To solve this one, I'm just going to add 4 to both sides. And what's my last step?
Square root.
Take the square root. And
Yeah, x plus minus 2.
what are the two square roots of 4?
-2.
-2 and 2. Notice -2 was repeated. Okay, we call that a repeated root. Okay. Watch what happens when you graph something that has a repeated root. Okay, it's x cubed plus 2x squared minus 4x minus 8. X cubed plus 2x squared minus 4x minus 8. Okay, watch what happens at -2. The graph is going to come up, it just touches it, and it goes away very quickly without crossing. Okay, anytime you have a repeated root, that's how it looks. It'll come up, it'll just touch the repeated root, and then go away from it very fast. And then it crosses again. What number is that right there? 2. +2. Okay, so it crosses at -2, that's a repeated root, and +2. So technically, there are still 3 answers to this problem. One of them is a repeat, though. So the answers are -2, repeated, and 2. Those are my 3 answers. Right, and the last one, this is one that, let's see. Factor by grouping might work on it, but let's just practice on the calculator. Okay, make sure you remember how to do it. So we get 2x cubed. This is always a good method to fall back on. If you get stuck with factor by grouping or you can't do it, just use the calculator. Minus 4x squared plus x minus 2. All right, it's a cubic. How many times could it cross the x-axis? It could cross 3. Could be 2 like the last problem. It could even be 1. Okay? But it can't be 0. Okay? One end is going to go down, the other end is going to go up, and it's connected forever. So if you go up and down forever and you never pick up your pencil, you're going to go through 0 at least once. Okay. So this is the one that it does only cross one time. Okay. How do I find where it crosses?
Do second calc.
0. Yep. And then it says pick a point somewhere to the left. Okay. Pick a point somewhere to the right. Okay. Now it's going to look between those dotted lines to find a root. And this time the root is at 2. Yep. The root is at 2. So if 2 is a root, what would be a factor of this? What do you put in front of that? X minus. All right? If 2 is a root, x minus it would be a factor. They didn't ask that here, but just good to keep that in mind. So if I divided f of x by x minus 2, what would the remainder be? Remember, this is a factor. So what does that mean if something's a factor and you divide it? Like 12 divided by 4. What's the remainder? 0. Okay. If something is a factor, it's going to divide in without remainder. Okay. So if you plug 2 into this top one, you're going to get 0. And we should, because that's where it crosses the axis. All right. Any question on that? All right. So those are the problems to try for tonight. A little fuzzy. Okay, it's on 171. Okay, it's 1, 2, 4 through 6, 9, 13, 15, 17, 19, 20, 25, and 32. All right, so just try those questions, and then tomorrow we'll go over them right away, and then we'll look at synthetic division, which I think most of you will find a little bit easier than long division.